Hello everyone, it's Mr. Keeney, and we are today starting our Unit 3 in Algebra Geometry 2. We're going to be talking about polygons. Today is all about classifying polygons, and we're going to talk about their parts too, and what makes them maybe special polygons, what kind of polygons we have. But first, we're going to talk about just a polygon and what a polygon is. I'm sure you've seen what a polygon is in your past math classes and experiences, but just as a reminder, a polygon is a closed figure, so that's our first blank, a closed plane figure, but I'm just going to say closed figure, a closed figure with the following properties. So it is formed by three or more line segments called sides. And each side intersects exactly two other sides, one at each endpoint, so that no two sides with a common endpoint are collinear. Now, we've seen a lot of examples here of polygons throughout math and going through, but the big things that we want to focus on is that our sides are line segments, so they are what we call straight, so there's no curves. Each side intersects two other sides, and it is a closed figure. So yeah, we're going to take a look at the different parts of it in this example. We just have one more blank to fill, which says each endpoint of a side is a vertex. In the vertex of the polygon, the plural version is say instead of vertexes, we're going to say vertices. That's how you say that plural form. And a polygon can be named by listing the vertices in consecutive order. So if I wanted to name this polygon, I could call this, and I'm going to go around this direction. I'm going to start at A just because I feel like it. I'm going to go around until I name all vertices. So I could name it polygon A, B, C, D, E. So that's one possible name. Another possible name for this could be, I could start anywhere. I could also name it, let's see, I could name it D, E, A, B, C. I just want to make sure that I'm going in that consecutive order. So these are possible names for the polygon. And we just list, like I said, the vertices in order. There's a lot of different names. There isn't just two. There's actually 10 different names for this one, since there's 5 vertices, and we can go either direction. I could have gone A, B, C, D, E, or I also could have said A, E, D, C, B. So I could go either clockwise or counterclockwise. As far as the vertices, so just making sure we know what the vertices are in a polygon, it's these points here, these corners, if you will, of where they're meeting. So the vertices A, B, C, D, and E. And again, those are what we choose to name our polygon. And then the last thing is sides, just making sure we know the parts of a polygon. We have 5 different sides in this one. We have line segment AB. Remember, these are segments. We have BC, we have CD, we have DE, and our last one, EA. And again, I can switch those, like AB could be called BA, et cetera, but just making sure we know the different parts of a polygon. And every polygon, I'm now down below here, every polygon, and I'm going to change colors, is either convex or concave. So for convex, here is an example of convex over here. This one would be convex, and I'm going to show you why. I'm going to show you that if I were to extend all these sides here of this polygon, you'll notice that none of the sides, once I extend them, go actually inside the shape. That's a way we could call it or recognize that it is convex. Now, how is that different than concave? So concave over here, a lot of my students in the past have thought, well, concave, it caves in. And we can see that here on this side. It comes in. And if I were to extend it, it goes inside the shape and it intersects another side of the polygon. So the same with this side here, it goes inside. So the reason that it goes inside the shape, it caves in, and once I extend it, this is the part that makes it concave. Now we're going to be in the business of classifying polygons. The first thing we're going to do is we're going to classify it by convex or concave, but then also we're going to classify it by the number of sides. This, I'm guessing for a lot of you, again, will be a review, so I'm going to run through it real quick. If we have a 3-sided polygon, that is what we would call a triangle. If we have a 4-sided one, that is what we call a quadrilateral. 5-sided is pentagon. 6-sided is hexagon. Excuse me, I almost forgot for a second. 7, I've heard it called a couple different ways. We're going to say heptagon. I have had students in the past that went to different schools. I called it a septagon. So if you're one of those, let me know because I'm kind of interested to see where that's coming from. 8 is octagon. 9 is nonagon. 10 is decagon. Oops, I put a D in there. Decagon. And then finally 12 is dodecagon. So these are those special names that we have for a sided, for whatever sided polygon. But sometimes we have, maybe a 17-sided polygon, or like what we're going to say here, an n-sided polygon. So if we have like a 17-sided, let me give that example, we can just call it a 17gon. So whatever the number of sides is, we're just going to do n-gon. So there's an example. Another example would be, let's say there's 100 sides. The name for that would be 100gon. We can just name the number of sides and then put -gon. So, and I'll highlight that too. The number of sides would get us the name 100gon. And then another way that we can also classify polygons is by talking about their sides and their angles. If we have, the first one I'm going to put down is equilateral. An equilateral polygon means that all sides in the polygon are congruent. We also could add something called equiangular. Now, equiangular is exactly how it sounds. Equiangular means all angles are equal, or all angles are congruent. Now, sometimes we'll have polygons, not always, but sometimes we will have polygons that are both equilateral and equiangular. All sides are congruent and all angles are congruent, and we have a special name for that. We call that a regular polygon. So a regular polygon is both equilateral and equiangular. So instead, if we see a polygon that has all sides congruent and all angles congruent, we're going to call that regular. We're not going to call it equilateral and equiangular. We have a special word for that. We call it regular. And then sometimes we have polygons that they don't have equal sides and they don't have equal angles. They just got a mixed match of all those parts. And so sometimes we'll just have none of this. We'll have none of the above. And that's okay. So we have talked about 3 different ways we're going to classify polygons. 1, whether it is concave or convex. 2, whether it is a triangle, quadrilateral, basically by the number of sides. And then finally here about those side lengths and angle measures. Is it equilateral, equiangular, or regular? So that's exactly what we're going to do on these 3 examples here. We are going to classify those 3 categories. So starting with number 1, the first thing is this concave or convex? And this one is convex because it does not cave in. There's no side, if I were to extend it, that's going to go inside the polygon. So it's convex. I notice that it has 4 sides, so I'm going to call it a quadrilateral. And the last thing is to look at the sides and the angles. Are they equal or are they not equal? So I'm noticing first that these angles are all right angles. That means they're all equal. They're all 90 degrees. So it's at least equiangular. Let's check to see if we have equal sides. We have 2 tick marks. That's a good start. But unfortunately, not all 4 sides are congruent. So it is not equilateral. The most specific we can get is that this is equiangular. So in this picture, we have a convex equiangular quadrilateral. What we're going to learn in the future is that actually is a rectangle, and I'm sure some of you guys do that already. On this next one, number 2, if I were to extend this side here, you'll notice that it intersects and it goes, inside the shape. So this is an example of concave. It's caving in. It is, let's count the sides. We got 1, 2, 3, 4, 5, 6 sides. So that would be a hexagon. And then they don't give me any information about the angles or the sides, so I can't say whether it's equilateral because I don't know if the sides are equal. And I can't say if it's equiangular because I don't know if the angles are equal. So I definitely can't say it's regular, which has to be both. So this is it. We would just say concave, hexagon, and then on those options earlier, this is one of those none of the above ones. So we just leave it as concave hexagon. And then finally here, this is a convex because there's no caving in. I'm going to count the number of sides. It looks like we got 1, 2, 3, 4, 5, 6, 7, 8, I believe. So it is a octagon. And then if you take a look here, all the sides are congruent. All of them have one tick mark. So it's equilateral. But before we name it that, I also notice that all the angles are equal. They all have one arc. So this is our first example of seeing a regular polygon. That means it's equiangular and equilateral. So those are 3 examples. You're going to have plenty of those on your assignment today. And then our last one here is a little algebraic problem. The head of a bolt is shaped like a regular hexagon. The big word is regular here. That means all sides and all angles are equal. The expressions shown represent the side lengths of the hexagonal bolt. That's a hard word. Find the length of a side, so just one side. Well, looking here, again, I know if it's regular, all the sides and all the angles are equal. Now, if I'm trying to find a side length, they give me 4x plus 3 and 5x minus 1. I don't know what x is, but I do know that in a regular polygon, these 2 sides, if they represent sides, they're going to have to be the same thing. So I set them equal to each other, and now I'm going to solve for x. So I'm going to take away 4x from both sides. Oops, there goes my screen. I hate it when it does that. These will cancel out. I'll bring down my 3. 5x minus 4x is just 1x or x. Bring down the negative 1 or the minus 1. And I'm going to get rid of that minus 1 by adding 1 to both sides to get 3 plus 1 is 4. Bring down the x, and these will cancel as well. So x equals 4, but remember, I'm trying to find a length of a side, not what x is. So I'm going to plug it back into just 5x minus 1, but instead of x, I'm going to do 5 times 4 minus 1. 5 times 4 is 20 minus 1, which is 19, and we're not going to forget our units, which is millimeters. So there we go. That is the conclusion of our 1.6 notes. Please let me know if you guys have any questions, and I will talk to you guys later. See ya.